In this video, we're going to look at writing trigonometric functions from graphs. This can be a little tricky just depending on what our graph is that we're getting. And bear in mind, this video is only going to focus on writing the equations for sine and cosine. The issue with a lot of these is, with all of them, is they can either be a sine function or a cosine function. So there's really infinite answers that you can have for these. So what I'm going to do is in this video, I'm going to kind of break each one of these two examples down, showing you how maybe you see a sine function, maybe you see a cosine function, and we just write in those transformations that give us that particular function. So let's go ahead, we'll jump straight in, and hopefully by the end of this video, you'll feel pretty good on writing these equations. So look at this first one. When I see this and I'm looking at it, I'm like, okay, well, I see either a sine function or I see a cosine function. Most of us are going to say, okay, well, the graph itself starts in the middle of an increase with that middle being on the y-axis. Well, then that's a sine function, and that's all fine and dandy. But what if I told you that you could have a cosine function that's got a phase shift? Well, we're going to write both of those just for whatever. That way you feel comfortable on doing both of them. So anyway, let's go ahead and start looking. The first thing that I typically do is I always find my midline. And I kind of made this easy because those dots, they're already there. But the midline is not bad. It's not hard to find. I'm only going to focus on the sine function first, and then we'll come back and redo it for cosine. But we know that our midline is plus 2. It's a vertical shift up 2. After finding that, I can then find that amplitude because it's simply the distance from the midline to the maximum. So I have 1, 2. I don't have a vertical reflection or a reflection here because my graph is going up this way. So that is definitely a easy way for us to see that. Now, I need to find my value of b, and I need to find if we have a phase shift. Now, clearly, when looking at this, if we know that we start in the middle of our increase on the y-axis for the sine function, we don't have a phase shift. So I can go ahead and just write in 0 here. You don't have to put the 0. That's fine. It doesn't matter. I've always done it where I personally like to see all of my transformations and then rewrite it at the end to make it look a little cleaner. But we do need to find the period of this function. So when I'm looking at the period here, I go from basically 0 all the way until my pattern repeats right here at 2 pi. So remember, period is always found by saying 2 pi over b. But if I want to find what my b value is, we just set 2 pi equal to 2 pi over b, and we solve for b. Multiply both sides by b, it gives me b, or 2 pi b equals 2 pi, divide by 2 pi, and we get b equals 1. So I can throw that right there. That's easy. And I'm done with sine. All right, sine function, easy, not hard at all. But again, let's say that maybe this time we see this cosine function. Well, for the cosine function, the midline is still going to be the same as well as the amplitude. We also know that our period for this would still be the same, even though people are like, well, you know, we go from pi over 2 or pi over 2 to technically 5 pi over 2. Well, that's still a distance of 2 pi, which we know simplifies when we solve for that value of b to give us 1. But the difference here is we have this phase shift, because normally cosine starts with its maximum on the y-axis, but we have moved a distance of pi over 2. And so with that distance move of pi over 2, we move to the right. Therefore, we have minus pi over 2. And there's my cosine function. So we could rewrite both of these functions. So I have f of x equals 2 sine of x plus 2. And there's my cleaned up version. Okay, and then for cosine, if I wrote it this way, we could say 2 cosine of x minus pi over 2 plus 2. And there's my two functions. All right. So hopefully that makes sense. Again, I start with my midline, then I move to my amplitude, and then I start looking at what the period would be, and then finally the phase shift if we have one. Okay. So let's try one more example here. And again, maybe I see a sine, so we'll go with sine here. Find that midline first. So this time we have -2. We've gone down 2. Let's find our amplitude. Well, we know that it's from here back down to the line. So I have that being a distance of 1, 2, 3. So our amplitude is 3. Now I need to find what the period would be. So we go from 0 to 4 pi. And so my period is 4 pi. Let me actually work this up here. You might not be able to see that. So 4 pi equals 2 pi over b. Multiply both sides by b. Gives me 4 pi b equals 2 pi. Divide by 4 pi. And that gives me b equals, simplifies to 1/2. So we have 1/2 x minus. And then do I have a phase shift? Nope. But I do have something else here. Notice this is a sine function, but it's decreasing. That means that we have had a vertical, not a vertical, it means that we have had a reflection over our midline. And we get that by getting that negative in there, okay? So we don't have a phase shift, and that's it. There's our sine function. So again, let's look at it from a cosine standpoint. Midline is going to be the same, so we go down 2. My amplitude is still going to be 3. Now, doesn't necessarily mean it's been reflected. So it all kind of depends upon how we're looking at this. I could have a phase shift to the right pi, and that would, because that's a minimum, that would state that the minimum started on the graph started on the minimum, and you did have a reflection. Or maybe you write it up here. Maybe we did a phase shift of pi to the left. So there's a couple of different ways that we can handle this. I just know that we have a phase shift of pi, and maybe I'm going to say pi to the left, because in doing that, I'm able to keep that a positive 3. So I literally am just saying that I went from here to here, okay? And our period is still going to be 1/2. So if I clean up these two, I have f of x equals -3 sine of 1/2 x minus 2. And then if we add it from a cosine standpoint, we have 3 cosine. And I'm going to distribute that value of b in, right? And that gives me 1/2 x plus pi over 2 minus 2. And there we go. So that is kind of our simplified versions of our formulas, or our functions rather, and that's how we graph. We take a graph and write the equations of them. So hopefully you feel pretty good with this. Again, there's infinite answers here, so you just go with whatever you feel is the easiest for you to see. But anyway, I hope it helps. Thanks for checking out the video, and I will see you next time.